Advanced Financial Modeling, Topic 2, Portfolio Optimization, Learning Objective number 3. We're going to add a risk-free borrowing rate to find an optimal levered portfolio on the capital allocation line, or also called the CAL. So here's what we've done so far. We have found an optimal set of portfolios, and we'll call that the envelope right here. However, if you could borrow at a fixed rate, risk-free, in other words, it's a fixed interest rate over the period, one of these portfolios is better than others. And that is this portfolio. If I have some rate RB, which is a rate I can borrow at, I could buy this portfolio, which is a tangency point of a line segment coming from RB touching the envelope, because I could invest in this particular envelope portfolio, and by using borrowing money, I could move along this line, which then totally dominates these points on the envelope. So borrowing is important because I can leverage one of these special portfolio, or one of these envelope portfolios. All right, so how we're going to do this? We need to first find this tangency given some borrowing rate, and then draw the capital allocation line, and then in future topics find points on this curve. So let's go ahead and do that. Let's go ahead and calculate find this this point. Just to give you an idea how I'm going to do that. This tangency is found by maximizing the slope of a line of a tangency point that comes from RB. So notice this could be right here, but by maximizing the slope of this line segment, it's going to ensure I get to this tangency point. The slope of that line, if you remember from high school, rise over run, my rise is going to be this Y segment, my run is going to be this X segment. So I could calculate that slope, and also called the Sharpe ratio in finance, by calculating that rise over run, which would be the return on the portfolio minus the borrowing rate divided by the standard deviation of the portfolio. And graphically, what that means, if you're looking at this point here, this is the rise, this is the run. The run is the sigma of the portfolio. The rise is the difference between the return of the portfolio and the borrowing rate. So let's go to the spreadsheet, take a look, and we're going to run a solver to maximize that slope. I have a place here for the slope. That's called the Sharpe, the borrowing Sharpe rate. In other words, it incorporates the expected return, the borrowing rate. And notice it's just a formula. The portfolio mean minus RB divided by portfolio vol is the slope of a line segment coming from RB. What I want to do is maximize that Sharpe. So I'm going to go data, and I notice also I've given this a name here called B Sharpe. And I'm going to go data, solver, and I want to click on maximize, and I'm going to put in my B Sharpe, looks like C10, and I want to eliminate the constraint on the mean. So I want to maximize Sharpe, 100% of your money still invested, still no short sales in this example, and hit solve. Solver found a solution. Okay, there's the solution. Put 69% of your money in US equities and 31% into emerging market. It maximizes this value. Now, theoretically, where should this line be? If my borrowing cost is 6%, I'm just going to draw on here, just don't do this, but just for fun. In theory, it should be right here. It should be right around here. That tangency from the borrowing rate should be right around here. So we can try to graph this point. However, if we want to graph the whole line segment, notice a couple things. I'm going to need 2 points to graph in Excel, or in my two-dimensional graph here. And by the way, I can't get on this part of the line segment. I can only get on this part of the line segment, because this part of the line segment would mean that I'm investing in RB. I can't invest at RB. I can only borrow at RB, so I can't get on this part of the line. I'm just going to wind up on this part of the line. So what I want to do, I'm going to create 2 points, which is one's going to be that tangency point, and another one is going to be an arbitrary point on that line segment up here, and then I can graph this line segment. So I am going to create an arbitrary point. We know what point 1 is. That's the maximizing the Sharpe. Point 2 is just going to be an arbitrary point. Here's one I'm going to pick. It's not so arbitrary. I'm going to say, what if you could borrow up to 50% of the value of your portfolio, which is a value set by many brokers. If you have $100 at the broker, the most they're going to lend you is $50, 50% of your portfolio value. So I'm going to use that. That point 2 is going to be using 50% leverage. In other words, if I had $1 invested, that's my $1 of equity I'm going to invest, I could borrow 50 cents and get $1.50 invested in the market. So how do I find this point 2? Well, I need a mean and a standard deviation to get this point 2. When you leverage a portfolio, in this case, you will get 150% of the volatility of this portfolio you're leveraging. However, you got to pay interest, or you're not going to get 150% of the return. So let's show the formula. The x in my point here is just going to be 150%, 1 plus the leverage of the standard deviation of this point. All right, so it's just 150% of that value. This value here, the y variable, is going to be 150% of the return of this, but I need to pay the borrowing cost. In this case, 50 cents times RB. So I've already set this up in the spreadsheet for you. And if I come down here, well, I need to do one more thing. Notice this is the optimal portfolio that maximizes the Sharpe ratio. So I'm going to copy these values that were generated through the solver, and I want to paste them here where it says OBP, Optimal Borrowing Portfolio, Alt-HVV. So this is that 1 point. It has 1479 vol and 933 mean. This is my RB point. However, here's my kind of arbitrary leverage point. The volatility of that portfolio, if I had $1 and I borrow 50 cents, I get 150% of the volatility. I get of this portfolio here. I get 150% of this number. I get 150% of the return also, but I need to pay 50 cents interest on the 50 cents. So it's minus 0.5 times the 6%. So there is my x and my y variables that I can add to the graph, together with the tangency point. And also notice I get the weights in U.S. equity, foreign equity, bonds, and so on are 150%. So here's the example. If I had $100, I borrow $50 at 6%, and I can put 150% of my money then into these individual assets, in which my borrowing is 50% or negative 50%. So let me add these data points here to the graph at the same time. So here's how I add a line segment to Excel graph. I'm going to get rid of that line here, the fake one here I just put in. If I can grab it. Oh. Let me make this bigger. it's not letting me make it bigger for now. So let's just add it. We're going to do a right click, select data, add. I'll call it a capital allocation line dash borrowing. My X variable, standard variable, standard deviations, I'm going to put in the 2 vols, not the 3, but the 2 vols. These 2 values right here. Being a little temperamental here. Let me try this one more time. It's going to be B28 to B30. I'm sorry, B28 to B29. Let me add that one more time. Again, it's just being a little temperamental. I'll call that CALB. B28. So B29. Oh well, I'm having trouble. Just make sure it's B28 to B29, and the Y variable is going to be the returns, which are going to be C28 to C29. And when you're done, you should get this beautiful graph that shows this line segment. Okay? And so what does this show me? One, it does seem to be the tangency from here, right? It does seem to be the tangency point. And what you see here is I can now invest on this line by leveraging this optimal borrowing portfolio. So what you see right away is I'd rather be on this line segment here than on the envelope here. So this line segment completely dominates these points on the envelope below the capital allocation line. So in this topic, we talked about how to add the borrowing to our envelope or our portfolio choice, and we created a capital allocation line.